In this video, we will understand and learn about the pH scale. This word pH value we hear quite often, right? So, what is this pH and what is the pH scale? Now, in the previous video, we understood that in aqueous solutions of acids and bases, the concentration of hydronium ion H3O plus and OH minus varies, okay, from 10 m, is 10 mole per liter, to 10 raised to minus 14 mole per liter. Okay, so a scientist or botanist, Sorensen, he proposed a logarithmic scale for expressing the concentration of H plus ions. So pH scale is nothing but the negative logarithm, the negative logarithm of the molar concentration of H plus ions. Okay. Now don't get scared. Just understand pH is nothing but minus log of concentration of H plus ion in a solution to the base 10. And if we know the logarithmic properties, this minus log x can be written as log of x to the power minus 1, okay, which is nothing but log of 1 upon concentration of hydrogen plus ions to the base 10. But this definition is what is understood by most people. And because H plus is coming from, we know that H plus plus H2O gives H3O plus. So we can also write as pH is nothing but negative log to the base 10 of hydronium ion concentration H3O plus. So for neutral solution, for acidic solution and for basic solution, what can be the pH? Okay. So for neutral solution, we saw that the concentration, neutral solution, or you can say or pure water also. Okay. We can say, as we learned in the last video, that concentration of hydronium ions is equal to concentration of OH minus ions, hydroxyl ions, and this was 1 into 10 raised to minus 7 mole per liter. Okay. Now that means for a neutral solution, what is pH? Negative log of this value, 1 into 10 raised to minus 7 to the base 10. So it's nothing but minus of this log value will be minus 7 because it is 10 raised to minus 7, right? 1 into 10 raised to minus 7 is 10 raised to minus 7. So log of 10 raised to minus 7 to the base 10 is minus 7. So already there is a minus sign in the front. So minus of minus sign 7 will become 7. So whenever pH is 7, we say it is a neutral solution or it is pure water. Okay. Now next is for acidic solution. For acidic solution, what is the pH value? So we know that in acidic solution, concentration of hydronium ions is greater than concentration of hydroxyl ions. Because what happens, let's say an example, in the previous video also we understood this concept, but just to reinforce, let's take an example of HCl. So HCl plus H2O is giving a strong acid, so single arrow, H3O plus plus Cl minus, correct? Now H2O by itself has some auto ionization, and what does H2O yield? We also learned this. 2H2O yields H3O plus plus OH minus, correct? So there is extra concentration of H3O plus compared to OH minus. That's what is reflected here. Therefore, if we write pH value for an acid, so Before that, this concentration of H3O plus, how much it should be. So we know the overall concentration of uh, H3O plus for a neutral solution was 1 into 10 raised to minus 7 mole per liter. So for an acidic solution, this should be greater than 1 into 10 raised to 7 mole per liter. Agreed? Now that means when we take the pH, that is negative log of this value, okay, pH, that is negative log of value which is somewhat greater than 1 into 10 raised to minus 7, and this is to the base 10. So that means anything having concentration higher than this value, let us say 10 raised to minus 6 is also greater than 10 raised to minus 7. So if I put 10 raised to minus 6, this would have been minus of minus 6 is nothing but 6. So any value greater than 10 raised to minus 7, its logarithmic value will give us less than 7. So whenever pH is less than 7, we call it as an acidic solution. Okay, I can simply conclude pH less than 7 for acidic solution. And on the other hand, for a basic solution, concentration of H3O plus is less than concentration of OH minus. So that means this is concentration of H3O plus is less than 1 into 10 raised to minus 7, and pH is nothing but negative log of a figure which is less than 1 into 10 raised to minus 7. Let's take 10 raised to minus 8. So log of 10 raised to minus 8 is minus 8. So minus of minus 8 is 8. That means this value is coming out to be greater than 7. So pH is greater than 7 for a basic solution. This is the distinction we need to understand. Okay. Now, a very strongly acidic solution will have pH close to 0. A very strongly basic solution will have pH closer to 14. Okay, you understand that, right? Now, just like equilibrium constant K, we have Ka for acids, ionization constant, Kb for base, and Kw for water. That's what we learned in previous video, right? So we have similarly like pH value, we also have pOH. So whenever pOH is mentioned, simply understand it is minus log of concentration of instead of H plus OH minus ions. Similarly, if suppose it's mentioned pKa, Ka is the ionization constant for acid, right? So pKa simply it is minus log of Ka to the base 10, and pKb for bases is nothing but minus log of Kb to the base 10, and similarly pKw is minus log of Kw to the base 10. Just like pH, these are other terms we might come across sometimes, and their meaning. Okay, so for example, pKw is nothing but pH plus pOH. So I just mentioned that here for a better understanding of pKw. So what is pKw? We wrote it as minus log of Kw to the base 10, right? Now, what is Kw? We know. So minus log of what is Kw? H3O plus concentration into OH minus concentration and to the base 10, right? And whenever we have product of two terms under the log, that means it is equal to sum of the two logs. So I will put minus outside. So log to the base 10 of, we can say H3O plus concentration plus log to the base 10 of OH minus concentration, and this. So when I open the this bracket, will be first term minus H3O plus concentration and log of that to the base 10, and minus of plus is minus OH minus concentration to the base 10. Okay. So what we can get is this is pKw, and this is minus log of H3O plus concentration. We already understood that it as pH. You see here pH, and what is log of concentration of minus log of concentration of OH minus it is POH. So can I write pKw is equal to pH plus POH? Okay, and we know that since we know the value of Kw, what is it? 1 into 10 raised to minus 14, okay, moles square per liter square, right? That means implies pKw is negative log of this figure to the base 10, which is nothing but 14. Correct? Implies we can say, for the purpose of understanding, I remove this because it's already written above. So we can continue with this. So what is pKw? pH plus POH is equal to, and that is why if we know pH, we can also find out POH. For a neutral solution, pH is 7, POH will be 7 definitely. For an acidic solution, pH is less than 7, therefore POH should be greater than 7. For a basic solution, pH is greater than 7, so POH is less than 7. So if suppose there is a simple question, let's see one simple question to understand this better. Let's say we want to calculate pH of 0.01 molar, that is moles per liter, aqueous solution of HCl. Okay. Now HCl is a strong acid, therefore it would ionize completely. Therefore H3O plus in 0.01 molar HCl will be approximately equal to concentration of the acid will be equal to 0.01 molar, because the other OH minus ion will be very very less. So pH is therefore negative log of concentration of H3O plus to the base 10. So negative log of what is 0.01, 10 raised to minus 12, so we can write it. Okay, write it minus log of 10 raised to minus 2 to the base 10. So minus of minus 2, which is nothing but 2. Now we can understand it as a qualitative term also, because HCl is a strong acid. We discussed that any strong acid has pH value closer to 0. So that is why we are getting the value of 2, which is closer to 0. Okay. And similarly, if you want to find pH of, let us say, 0.01 molar, that is mole per liter, aqueous solution of NaOH. NaOH is a strong base, sodium hydroxide. Okay. How do we find this? In a similar way. Okay. What is, in a case of a strong base, the OH minus ions are higher in concentration. So here I will write for acidic terms, concentration of H3O plus is greater than that of OH minus ion, because it's a strong acid. Okay, and that's why we can approximately say in the overall solution concentration of 0.01 molar, most of it will be H3O plus. So we approximated concentration of H3O plus as the same as that of HCl. Similarly, for a basic solution, concentration of OH minus is greater than concentration of H3O plus. So we can approximately say this is approximately equal to concentration of NaOH, which is 0.01 molar in this case. Okay. Now we have Kw, which is ionic product constant for water. So it is nothing but we know already that H3O plus concentration multiplied by OH minus concentration, and its value is 1 into 10 raised to minus 4. Units are moles square per liter square. now, because pH is related with concentration of H3O plus, we have to find the concentration of H3O plus, that is Kw divided by concentration of OH minus. That is 1 into 10 raised to minus 14 divided by concentration of OH minus is 0.01 molar. Okay, this is 10 raised to minus. So 10 raised to minus 14 divided by 10 raised to is equal to 10 raised to minus 12. Okay, so therefore pH is equal to negative log of hydronium ion concentration to the base 10 of negative log of 10 raised to minus 12 to the base 10, which is minus of minus 12, which is 12. So as you can see, for a strong base, the value is coming closer to 14, and for a strong acid, the value is coming closer to 0. Okay, this clarifies the concept, I hope. So in the next session video, we will discuss the concept of buffer solutions.